ठीक है. So this is the last session of your midterm, and today we will design the smooth DC supply to study the operation of filter for smooth DC supply. Uh, so what is filter and how the filter works, and how we will design the filter and regulator in this lab. So as we have discussed in previous sections, that for DC power supply, these are the sub-blocks. This is the input voltage of the outlet wall. Okay, this is the plug in the wall. We will insert the switch here. This switch will take 220 volt and then this 220 volt will be passed from the sample transformer, and this transformer will convert this into a low voltage, either 6 either 12 F, and then the output of transformer is given to rectifier. This is the rectifier circuit. This rectifier can be center tape, bridge rectifier, center tape, folio rectifier, or bridge rectifier. Generally we use bridge rectifier. And the output of the bridge rectifier, for example, this is the input. So this is the also output of AC, and the rectifier output is like this. You know this is pulsating DC. So we will remove this pulsation. So for pulsation point of view, we will pass this output from the filter circuits, and this filter will be RC circuits, either capacitor. Capacitor will filter this. How the capacitor will do function, we will study here in theory. After that, we will pass this from the regulator IC, and this is the final output in the form of DC. So up to now we have discussed this portion, and this portion. Today we will discuss these two blocks, and this is the overall block diagram of the DC power supply. So in today's lab we will design the DC power supply. So power supply filters. A power supply filter ideally eliminates the fluctuation in the output voltage of half-wave or full-wave rectifier and produce the constant level of DC voltage. The filter is necessary because the electronic circuit requires constant source of DC, constant source of DC. Neither it requires fluctuated source. So they need constant source. For constant source, we will remove these fluctuation of the DC voltage and current to provide the power and biasing the proper operation. And you know what is meant by biasing. To apply a DC voltage. The filter are implemented with capacitor as you will see in this section. The voltage regulation in the power supply is usually done with integrated circuit IC. We will use filter, and for filter we will use the capacitor. For filter we will use the capacitor, and for regulation we will use the integrated circuits ICs, and this IC will be 7805 for positive and 7905 or something. This is for negative regulation. 78, when the IC regulator IC start from 78, so this will be positive, and when the name of the code of the model number of integrated IC start from 79, so this will be negative. A voltage required prevent the changes in the filter DC voltage due to the variation in the input voltage or the load. In most power supply application, the standard frequency is 50 Hz. For example, in previous all classes, we designed the half, full wave, two type of full wave rectifier, but we use the frequency 50 Hz. And the most power supply application, the standard 50 Hz AC power line voltage must be converted into approximately constant DC voltage. The 50 Hz pulsation of the DC output of the half-wave rectifier or 100 Hz pulsation output of full-wave rectifier. You know that in half-wave rectifier, the input and output frequency are same. So if this is a half-wave rectifier, so the input and output frequency will be 50-50. But in the case of full-wave rectifier, the input frequency is 50, so the output fluctuation frequency will be 100. You know it is double. So it means that this pulsation will be removed. It must be filtered to reduce the large variation. So इसको हम क्या करेंगे? We will pass this from the rectifier circuit to reduce the large voltage variation. So the figure 2.4 illustrates the filtering concept, showing a nearly smooth DC power supply system. So this is the input voltage to the full wave rectifier, and this is the pulsating output of the full wave rectifier. When you pass this portion from the filter, so you will see this is like this. Here this is a more fluctuation, here the fluctuation is low. So how this work? So capacitor input filter, a half-wave rectifier with capacitor input filter is shown in the figure 2.5. The filter is simply capacitor connected in the rectifier output to the ground. RL represent the principle explained here. This is the voltage applied, this is the diode, and this is the load resistor. Without capacitor, this was the half-wave rectifier. But when we insert the capacitor here and load here, then the output will be filter as compared to previous without capacitor circuit. How this work? As you know that if there is a no capacitor, then the circuit will be like this. And the output across the load will be like this. So there is a strong fluctuation here. But when we apply the capacitor here, this is called input capacitor. Yes, this is below from the before from the load resistor. So how this works? So when the diode is forward bias, it means here. So consider the first faulty cycle. So in faulty cycle, the capacitor is initially uncharged. So when the capacitor is initially uncharged, so you have studied in your circuit classes and circuit course that when the capacitor is initially uncharged, it will behave like short circuit, and when the capacitor become full charge, it will behave like open source and it will behave like battery. So when this circuit, in this case, it becomes short circuit. When it becomes short circuit, no current will be flow approximately here. So in, then the capacitor will become charged, applying this loop. So you know that the capacitor will be charged. This is the charging portion. Vp minus 0.7 mean if this is not ideal diode, then the voltage will be Vp minus 0.7 volt, maximum volt at night. If this is ideal, then it will become Vpn. When the this portion of the circuits, the waveform start from here to here, this portion. In this portion, the value of the input will become smaller as compared to this. So in this portion, it is seen here, the capacitor will be discharged. When the capacitor will be discharged, in this portion you see here it becomes charged up to Vp out minus 0.07, and from that point toward that point the capacitor will be discharged. So when the capacitor will be discharged, either you see that from this portion to this portion the diode will be reverse biased. Why? Because the capacitor has charge up to Vp minus 0.7, and when we consider this portion, so this voltage is smaller as compared to this, and you know that if this is less positive as compared to this, then the diode will be reverse biased. So that is why in this portion the diode is reverse biased. When the diode is reverse biased, it will be open circuit. So when the diode in this portion is open circuit, so there will be no current flow here. So the current will be flow in this circuit, and the capacitor will be discharged through this resistor. Capacitor will be discharged through this resistor. So when from here to here, this portion, the capacitor will be discharged through resistor RA. But it is the property of the RC circuit that it charges quickly but discharges slowly. It has been proved by equations. Either you have studied this in your diploma classes, either in circuit analysis classes, uh, and you will also study again in your AC circuit analysis course. But hope you know that the capacitor is charged quickly and the capacitor will be discharged slowly. So here the capacitor will be discharged slowly, and you know this is the output, was the output of the DC output of the half wave rectifier. So when this portion when this portion is started, then the capacitor will become then the diode will become forward bias again, and the capacitor will be charged again. So it means from this portion to this portion the capacitor will be charged, and from this portion to this portion the capacitor will be discharged, and this portion the capacitor will be charged, and another portion this will be discharged. So the capacitor will be charged and discharged, but you know the capacitor is charged quickly. So for charging it takes such much time, and for discharging it takes large time. So when we see here, so from this portion to this it will be charged. So you know this is the charging, and from here to here this will be discharged, from here to here this will be discharged but slowly, and from this portion to that they will be charged and then discharged. So you see that the output will be like this. If this is the input voltage and this is the output voltage, this was the output voltage of what? Half wave rectifier without filter. If we consider the filter operation, so in this portion the diode will become charged. In this portion the capacitor will become charged, and from here to here this will become discharged, and then it becomes charged, and here it will become discharged. And so you see that the output with filter will behave like this. So you see the fluctuation here is smaller as compared to fluctuation here. It means by applying the capacitor, the output of the half wave rectifier will be filtered and the fluctuation will be reduced. When we apply the regulator IC, so the fluctuation will become hours. Now the variation from this peak to this peak, this is called peak to peak variation, and it is denoted by a factor which is called ripple factor. So what is the ripple voltage? You can read this portion and I have explained here. So the ripple voltage, what is meant by ripple voltage? As you have seen that the capacitor quickly charged at the beginning of the cycle and slowly discharged through RL after the positive peak of the input voltage. When the diode is reverse biased, the variation in the capacitor voltage due to charging and discharging is called ripple voltage. From this portion to this it becomes charged, and from this to this discharge. So the variation from charging to discharging is very small. This is charging value and this is discharging value. This is charging value and this is discharging value. Charging, discharging. So this value is small. For example, here this was maximum, this was zero. This variation was large. Now this is maximum charging voltage. This is minimum discharging voltage. Then it becomes maximum charging. Then it becomes maximum discharging. So the variation from charge to discharge, this is called ripple voltage. Ripple voltage. Generally the ripple is undesirable. This is undesirable. Undesirable means that we doesn't want the ripple. we want to reduce the fluctuation. So the ripple voltage shows some variation, but this variation is undesirable. We did not want this variation. If there is a variation, if the variation between the charging and discharging is zero, so it means this is very good. But for this, you will use the high capacitor, and to reduce this ripple voltage, we will use another circuits, which is integrated circuit, which is the uh, regulated IC. So it means that it is undesirable. I have explained this word. This is undesirable. Thus, the smaller ripple, better the filtering action. If the ripple voltage is smaller, mean if this is zero, then this is very good. And if this is approximately zero, this is good. So this was the charging and discharging variation. This was the charging and discharging variation that you uh, so you see here, this dotted was the output of the half-wave rectifier, and this blue one is the output of the filter. So this is the maximum charging value, and this is the after discharging this value. So the variation from this portion to this portion is called ripple voltage. From this portion to this, when you use, this is the small capacitor. If you use the value of capacitors high, then it become like this. So here the filtering operation is best as compared to this, as the variation is small. So smaller ripple mean more efficient filtering. Generally, the large capacitor value, smaller will be the ripple. So and for output, this is the output of the Fourier rectifier, and this is the filter operation. What is meant by ripple factor? The ripple factor is the indication of the effectiveness of the filter is defined as, it is denoted by R, and it is the ratio of the VR divided by VDC. VR ripple mean the ripple voltage, and VDC mean the average value of the DC, average value of the output. So where the VR PP is the peak to peak ripple voltage, and the VDC is the average value of the uh, average value of the output voltage. So lower the ripple factor, अगर ripple factor की value smaller है, it means that better is the filtering operation. For example, here you see, this is the VDC and this is the peak to peak value. Peak to, this is ripple voltage from peak to low voltage. This is ripple voltage from peak to peak. This is the ripple VR PP. PP means peak to peak. VR mean ripple voltage from here to here, from here to here, and from peak to peak mean this. So how you will calculate, this is the your theory point of view. We will not use this in our practical simulation, but this is your theory of the electronics. So how you will calculate the ripple factor? So ripple factor can be calculated by VRPP divided by VDC. VRPP is the peak to peak voltage, and the VDC is the average voltage. So how we calculate this and this? Then we will divide, so we will calculate the R. So for VRP is the 1 over FRLC. C is the capacitor used for filtering, RL is the load resistance, and F is the frequency. If this is half wave rectifier, then input and output frequency will be same. If this is full wave rectifier, So the input frequency is 50, then you will write the F is 100, as this is double. So you will calculate the ripple factor by this formula, in VDC by this formula, 1 minus 1 over 2 FLRLC into VP secondary. VP secondary. So these are the formulas, how this formula is derived. So we are not interested in derivation of this formula, but for your numerical point of view in theory class, you can use this. This equation for the VRPP, and this is for VDC. Then divide this by this, so you will get the ripple factor. So if you are interested in this portion, so see the book of light, and I have taken this portion from the flight book. So here these are numerical problem, and you can solve this numerical problem to this equation. Since search current in the capacitor input filter, we will design here this in this is the task of we will design the regulated DC power supply, and we will use bridge rectifier. This is our the lab task, and I will give the lab assignments or the lab task for you, that you will design the same circuit for center tape and for half rectifier. Hope you will understand that in simulation point of view, I will simulate the regulated IC for bridge rectifier. Is in common sources we use this, and for task point of view, you will design the same for half wave rectifier and center tape full wave rectifier. So the surge current in the capacitor input filter before switch to figure 231, since 231, 31A is closed. The filter capacitor is unchanged at the instant of the switch is closed. We have not used the switch. Before the switch in the figure 231A is closed, the filter capacitor is unchanged. At the instant the switch is closed, the voltage is connected to the bridge and unchanged. The capacitor appears as short as shown in the figure. Here we use the switch for seeing the operation, but no need of this portion. This produces an initial surge I surge through the two forward bias diode D1 and D2. The worst case will be occur when this in forward when this is maximum voltage appear. No need of this. So what is mean by voltage regulator? So when you do the filter operation, you get the output, but it has some fluctuation. So, and you know that our circuit require the smooth DC. For example, you when you want to design a DC power supply for a specific device, for example, our mobile charger is a DC power supply. So it provides a constant DC current to our mobile phone. So it means that there is some ripples in the output of the filter. So if you want to remove this, so you will use the voltage regulator. While the filter can reduce the ripple from the power supplies to a low value, most effective approach is the combination of capacitor input filter used with a voltage regulator. This is the best method to produce smooth, that we will use the input capacitor filter with voltage regulator IC. Voltage regulator is connected in the output of the filter rectifier and maintains the constant output voltage. For example, see here, this is the output of rectifier, and it is the input from the rectifier. From the rectifier means this is this portion. You see, this is the input from outlet 1 switch plug, and this is the output of transformer, and this output is given to the bridge rectifier, and this is the output of the bridge rectifier and input to the filter. Output from the bridge and input to the filter. So he says that the input from the rectifier to this is the input capacitor, this is the regulator IC, and this is the output capacitor. And here we will use the load resistor. So this circuit show the regulator. This is circuit show the overall DC power supply. That this is the first block switch, this is the second block transformer, this is the third block rectifier, this is the filter block, and this is the regulator block. This is the output. So here we have discussed this portion. You can read. So what is meant by percentage regulation? It will regulate the value, regulate to a specific constant value. So what is the percentage regulation? Percentage regulation means the output variation divided by input variation multiplied by 100. And you can calculate the load regulation from no load minus full load divided by full load. No load means this is no load. If we take the output from here, just here, this is no load. And this is the load when we apply the resistor here. This is load. If this is become short circuit, this is full load. Either short circuit, we can't do short circuit, but it is approximately. So it means when the load is high. So load high means the current is high.
ये आवाज हम लग स्लो थोड़ा लग दोबारा एक्सप्लेन करेगा नो लोड हो.
Okay, so in no load there are two operations, no load operation and full load operation, and you will study this no load and full load operation for other components, other appliances or devices in your whole degree. For example, you will test the no load test for the transformer, full load test for the transformer, and calculate the voltage regulation for transformer. So here we will calculate the regulation for our power supply. So we will calculate full load, no load, V no load minus V full load divided by V full load. What is meant by no load? So if we don't use this portion, this, and we take output from here, so it means that there is no, we have not applied any load here. So this is no load operation. If we apply a resistor here, so this is load operation. And if the current in this load is maximum mean, then this is called full load operation. And this is again your theory point of view. We will not touch this in the lab, but when you are interested to know what is the voltage regulation and how we will use this formula, so you can study this in the flight book, and there is some numerical problem on it. But this is the very important formula. You have to memorize this formula, that what is meant by line regulation. From the variation from no load to full load divided by full load, this is called voltage regulation. When you multiply this by 100, so this is called percentage voltage regulation. वेरिएशन फ्रॉम नो लोड टू फुल लोड। अगर आप एक पावर सप्लाई आपने डिज़ाइन किया और आपने प्लग इन किए, अब आप इस पर कोई लोड नहीं चला दी, किसी सर्किट को आप इससे नहीं चला दी, तो उस वक्त इसकी जो वोल्टेज है दिस इज कॉल्ड नो लोड। अगर आप इस पर कोई सर्किट लगा दी तो इस पर जो वोल्टेज दिस इज कॉल्ड लोड ऑपरेशन। अगर ये इधर आपके साथ लोड मैक्सिमम हो, लोड मैक्सिमम का मतलब है करंट बहुत ज़्यादा, दिस इज कॉल्ड फुल लोड। So this is called the no load and full load operation. So hope you have understand the theory behind uh, today lab. That in today lab
Sir,
we will study we have studied two components. One is filter and one is regulator. The filter do the operation that it reduce the fluctuation, pulsation. But when the pulsation reduced by the filter, so there are some variation also. So it can be removed from the from the regulator IC. And here we will use the 7805 IC for the regulation point of view. G.
سر جدي کې مونږ دا کپسټر ولې استعمالو په دغه معاملې باندې کې پې نشم سر
कैपेसिटर हम इसलिए यूज़ करते हैं। अब इसका ऑपरेशन अभी मैंने पढ़ लिया इधर कि ये जब चार्ज होती है, ये देखिए जब कैपेसिटर चार्ज होती है, सो या तक कैपेसिटर चार्ज होती है, फिर कैपेसिटर स्लोली डिस्चार्ज होती है। सो इसके बाद चार्ज थे, स्लोली डिस्चार्ज थे। तो यहाँ ये जो इनिशियल वाली वैल्यू था, इस में वेरिएशन ज़्यादा ना, ये मैक्सिमम था, इसका 0 मिनिमम था, तो इसमें चेंजेस बहुत ज़्यादा थे। यह हमारी डिवाइस को ज़्यादा नुकसान पहुंचा देगा। अगर हम ये इसको यूज़ करें, इसमें तकरीबन वेरिएशन कम है। अगर आपके साथ ब्रिज रेक्टिफायर है फुल वेव, इसमें देखिए इसमें वेरिएशन इसकी निस्बत बहुत कम है, और इट इज़ ओनली ड्यू टू द कैपेसिटर। अगर कैपेसिटर आप लगाए तो उसका चार्जिंग और डिस्चार्जिंग का जो प्रॉपर्टी है, इससे हम इस पर प्रोसेस को रिड्यूस करें। लेकिन ये जो फ्लक्चुएशन है ये थोड़ा और भी ज़्यादा है, तो इसको कंप्लीट ख़त्म करने के लिए हम क्या यूज़ करते हैं, रेगुलेटर आईसी। سامي كيديش फुल ब्रिज रेक्टिफायर है, उसका अगर आपको पता है, ये था हमारा क्या this was our previous task, and you see this is 215 or 315.
315.
And this is the 1 and 4 milli, and this is the 3.2 volt, and this was the output of the our, and you see that this is a fluctuation. So now we will use the capacitor to remove this and regulator. So for this we will use capacitor this is our generic capacitor. And regulator, per regulator you can type 7805. You see here 7805. This is 5 volt. And if you want, let's use this, then we will use what we have to. This. Okay. In volt. Take this 1 millivolt, then check it. 7 volt. This is now approximately 5 volt. Okay. So how we will use the capacitor and integrated circuit. So this is the capacitor. This is one capacitor.
سر د جنریک نه څه مطلب دی چې موږ هر یو دغه کې جنریک اخلو؟
जेनेरिक का फायदा ये होता है ना कि ये अपने आप को ऑटोमेटिकली इसके मुताबिक कर देता है, इसलिए मैं हम जेनेरिक यूज़ करते हैं कि जब आप प्रैक्टिकली इसको डिज़ाइन करते हैं तो फिर इसकी क्वालिटी को आप देखेंगे, ठीक है।
यस सर.
You may see here, this is the input capacitor, this is output capacitor, this is the regulator. So if we connect let's see without ground that what they do, but we will use the ground here. You see this is approximately constant. This is due to ground. We remove this portion, then we will put it. It is okay. So here you see that this is the see here, this is the output of the filter, and this is the output. This is the output of the bridge rectifier. This is the output of regulator. So you see this regulation is approximately constant value. And if I remove this portion and when we use switch here, up to now you have studied that when I use, sorry, this was very strong mistake.
سر دا ايه خو موږ نه کریکټ کړی کنه اوس سکوت ته
ایم نه دې ځکه خو دا زما سره داسې straight line راکوي کنه. But here you see the value will be, for example, زه لا غلط څنګه دې شي لږ غاټ شو پته نه لګي چې دا ولې نه دی هغه شان څنګه داسې horizontal لپاره موږ دا استعمالوو چې explicit شي.
سره دا بلو کې دا وړکې نوب وي دا
چې داسې
دا اورنج کلر نه کیږي دا اورنج نه کیږي دا کنه کم کوي نور دا خو ما امپلیټیوډ ختم کړ سره دا کم کوي دا وړکې لګ دا غټ نه سره دا غټ دا واپس بوځي بس دغه نه کیږي کولاوي.
So you see here, this is the output and this is the regulated output. So this is approximately straight line. And when we increase the value of the capacitor, so then it will become very good. For example, this is 1 nano. If we convert this into microfarad, and this has become 1 microfarad, and this has become 1 microfarad, and then so it means that if you increase the value of the capacitor, the filter operation will be good, and if we reduce the value of the capacitor, so the filter operation will be not good. دا پس کې چې څومره کې له دې شکل تا وړي سي دا ویریشن ته وګورئ که نه نو دا به تا ته بیا دا څه معلومات غواړي یار ठीक है. So this is our today lab. In today lab we study that how we will use the filter, how we will use the filter and regulator for the DC power supply. So you design this circuit and after designing this you also calculate that how you will use this is center tape rectifier and for half wave rectifier. This is your task that use filter for half tape. Taped rectifier only filter. ठीक है regulator तब लगा and design
څنګه سر جی
صرف فلټر ولګوي دا ریګولیټر آی سی په دې کې مه لګوئ دا چې کوم دي که نه دې کې صرف فلټر کیپیسټر ولګوئ او دا یې خو زه دمه وکړو ان ډیزاین ریګولیټډ پاور سپلای ما چې درسره کوم څیز شیر کړو که نه په دې کې شته ډیزاین ریګولیټډ سپلای پاور سپلای فرام برج ریکټیفایر دا تاسو ته ما اوس وکړو दस टास्क ठीक है कि आप क्या करें हाफ वेव और सेंटर टेप के लिए कर दें फॉर एग्जांपल इधर उसने किया है ठीक है ये जो मैंने आपके साथ शेयर किया था क्या चीज़ मेरे को एंटीना वाला ये देखिए हाफ वेव के लिए तो इसने इस तरह किया आप इसको कर दें लेकिन इसकी जगह मैंने आपको मालूम है हाफ वेव के बारे में हमने ट्रांसफार्मर यूज़ किया था तो आप वही ट्रांसफार्मर यूज़ करें और सेंसिटिव के लिए भी इस तरह कैपेसिटर लगाए और आप फिर ऑपरेशन को चेक करें उधर भी लोड रजिस्टर से पहले लगा लें फिर चेक करें और इस तरह अगर ये तो मैंने कर दिया तो आप इसको दोबारा कर दें ये बात ठीक है थैंक यू और अभी आप
ओके सर
स्क्रीन अगर शेयर कर सकते हैं तो शेयर